All right, so first lesson for Unit 6, definition of inverse functions. Hopefully your objective is written down by now. Students will be able to find the inverse of a function. If you haven't written it down yet, it's at the top of every slide also. All right, so for our first concept here, it's talking about a relation. So a relation is any set of ordered pairs or anything that can be written as a set of ordered pairs, both finite and infinite. So examples of relations, I can see them as ordered pairs. So these are ordered pairs. I can see them as in a table, because in my table I have the ordered pairs, -8, +18, 7, -5, 0, -1. I can see them as equations. So as equations, I can write them as ordered pairs. So like, for example, if I plug in x is 1, what do I get for y? That's 3 times 1 is 3. 3 plus 7 is 10. So my y value is 10. So equations, I can write them as ordered pairs by whatever I plug in and whatever I get for an answer. That's my pair. And then I also can see them as a graph. Because I can see the 0, 0 is a coordinate point here. I also have 1, 1 and -1, -1. So basically anything that you can write as as an ordered pair is called a relation. Okay? You have x and you have a y for all of them. All right, so let's look at now a function. How do you know if something is a function? So a function is any relation where there is a one-to-one relationship between the x coordinates and the corresponding y coordinate. So a function is a relation in which each value of the domain is paired with exactly one value of the range. Okay? In other words, this is every x value. So every x value, let me rewrite that. Every x value has exactly one y value. That's what it means to be a function, is it has to have a one-to-one ratio, relationship. And then every x has exactly one y. It's 1 to 1. So if I look at my examples, in my coordinate pairs, I have -2 for my x, is paired with a 6. 3 is paired with -4. 5 is paired with 0. 7 is paired with 8. So I can see all of my x's are different, which means every x has exactly one y. In an equation, I can plug in an x and I'll still get one y. So here, if I plug in x equals 1, 3 times 1 is 3. 3 plus 7 is 10. So my x of 1, I only got one output out of it. I got a 10 out of it, okay? And then in a graph, it needs to pass the vertical line test. So on a graph, it needs to pass the vertical line test. Okay, meaning if I were to get a vertical line and pass it through this graph multiple times, just going through like vertically. So if I have this line, then I have this line, and I just keep going through vertically with a whole bunch of different lines. My curve will only touch the vertical line one time. That's what the vertical line test means. If I take a pencil, for example, and I just go straight across the graph like this, then I'm only going to touch the curve one time on my vertical line all the way across. So then that means it passed the vertical line test, okay? So then it'd be a function. However, like if on this example over here, if I pass my vertical line through here, that actually passed through the line 2 times. It goes through this coordinate point and it goes through this coordinate point. It's passing 2 times instead of 1, so then it's not a function, okay? So this one does not pass the vertical line test. It's crossing the vertical line 2 times, so then it's not a function. As coordinate pairs, I can see the -2 is paired with the 6, and the -2 is paired with the 0. So -2 is paired with 2 different y values, so then it's not a function. For the equation, if I were to plug in x of 1, oops, that was on the pen. If I plug in x equals 1 into my function here, sorry, I shouldn't say function, to my equation, if I plug in 1 here, 1 plus 3 gives you 4, and then what's the square root of 4? 2, but then I have this plus or minus in the front. So this is telling me that I have a y, I have a y of 2 and a y of -2. So my x value of 1, I actually get 2 y values. So that is not good. That is not a function. Okay. So the main thing is, again, in order for it to be a function, every x needs to have exactly 1 y value. If it has more than 1, then it's not a function. So next, let's go over the inverse now. So our main goal is that we need to find the inverse of a function. So we talked about a relation, we talked about what a function is. Now we need to talk about what's the inverse, okay? So in order for something to be an inverse of a function or relation, is a set of ordered pairs, BA, which we get by interchanging or switching the coordinates of each point AB in the original relation or function, okay? So what that's saying is if my function had coordinate pairs of A comma B, then the inverse function would be the coordinates B comma A. For example, if this was 1 comma 2 for the function, then the inverse would be, switch them, it'd be a 2 comma 1. You just switch the x and the y, okay? All right, so then for inverse function, we say f of x is the original. Then this f inverse of x is the inverse function. And then the f to the -1 of x, that's called, or we read it as the inverse of f of x, or f inverse of x. I kind of just switch from those two on and off. It doesn't really matter. Just know that we don't say f to the -1 of x. We read it as f inverse of x, or the inverse of f of x. Okay, so the original function, we just say f of x. And then the inverse, we say it's f inverse of x. But the main thing is inverse, we switch the x and the y coordinates. All right, so let's look at our first example here. It says to find the inverse of a finite set of ordered pairs, we need to interchange or switch the x and y coordinates in all ordered pairs. So the directions up here says for part A, find the inverse of these coordinate points. And then part B, we have to determine if the inverse is also a function, and we need to explain, okay? So part A, we find the inverse. Part B, then we look at the inverse and determine if it's also a function. So my coordinate pairs are over here. I can see -5, 2, -3, -9, 7, 2, 0, 8. That's my function. Now to find the inverse for part A, I'm just going to switch the coordinate points. So part A, in order to find the inverse, I'm going to just switch these. So it's going to be my curly bracket, parenthesis, 2, -5, comma. Then my next one, these switch. So it would be -9, -3, comma. The next one would be 2, 7. And then the last one would be 8, 0. And then close it off with a curly bracket at the end. To draw your curly brackets, you kind of just do like a loop and then like a little pointy thing, and then you close off another loop. But sometimes I do it really fast, so you can't even tell what it looks like, but it's you do a loop and then a pointy and then another loop at the end. All right, so that's the inverse. All I did was switch the coordinates, okay? Now for part B says to determine if the inverse is also a function and explain why or why not. So remember, in order for it to be a function, each x has to have its own y. If you have x's that are the same with multiple y's, then it's not a function. So the main thing is I'm looking at the x values, the domain. I have a 2, a -9, a 2, and an 8. So are any of my x's repeating? Do I have an x that shows up twice? The 2, right? And then you check the y's. 2 is matched up with -5 and 7. Those are 2 different y's. So therefore, this one is not a function. Okay? So we would say the inverse is not a function because the x value of 2 has 2 different y values. Okay? Because my x value of 2 is repeated with 2 different y values, then it's not a function. It's not a 1-to-1 ratio, so it's not a function. All right, so now let's look at a different example. Let's say I have a graph this time with just dots here. I just have a graph with dots. The directions say to find the inverse of a function shown in the graph, and then is the inverse also a function, and we need to explain. And then the directions are given to us here. It says write the ordered pairs for the given function, and then find the inverse by switching the coordinates of all the points, okay? So first you need to get the coordinate points for each point. So this one here on the far left, remember it's a x, y. X, y. So first you look at the x value. My x value there is a -3, and my y value is a 1. For my next coordinate down here, that x is 0. The y coordinate is -1. And then the next one to the left is actually the top one over here. My x value is 2. My y value is 4. And then for the last one down here, my x is 3. My y is -2. All right, so then for part A, we need to find the inverse. Now that I have the coordinates, I can write them for the inverse. So draw your curly bracket, parentheses. I like to go from left to right. So the left one is here. That's going to switch to 1, -3, comma. My next one to the left is this one. 0, -1. It's going to switch to -1, 0, comma. The next one to the left is actually the top one. So that 2, 4 is going to switch to 4, 2. And then the last one to the right, that 3, -2 is going to switch to -2, comma 3. And then close the brackets. I have my 4 coordinates, and then I need to check at the check the domain. Are any of the x's repeating? So I see a 1, -1, 4, and -2. All of those are different, so because they're all different, every x has its own y. So then this one we would say, yes, the inverse is a function because every x value has its own y value. So for part B, we say the inverse is a function because, oh my gosh, I can't write today. Because every x value has its own y value. So then it is a function. All right, so now we're going to be looking at tables. So if you look at this table, I think you might have missing values on your notes. So go ahead and copy them. I think there are missing things on there. But we got 7, 6, 3, 1, -3, 2, and 4, 1. This is on a table now. But on a table, you still have to write the inverse as coordinate pairs. So for part A, for the inverse, I still have to write them as a coordinate pair. So my curly bracket, this coordinate pair is 7, 6, so I'm going to just switch them. Basically, the x's and the y's are just going to switch still. So that's going to be a 6, 7. Then I have a 1, 3, 2, -3, and 1, 4. Okay, so I'm switching the coordinate pairs for the inverse. Part B, just like we did on all the previous ones, we got to check the x's. I have a 6, a 1, a 2, and a 1. Are any of my x's repeating? The 1. Then you check, are the y's different? I have a 1, 3, and a 1, 4. My y is different, so then this is not a function.
If it was like
if this was 1, 3, then yes, it is a function because 1 is still just paired with 3. 1 is paired with 3, it's just showing up twice, but that would still be a function because it has the same y value, okay? It's just that the 4 is different. The y value is different. 2 different y values, so then it's not a function. So we say the inverse is not a function because the x value of 1 has 2 different y values. So the part A and the part B is basically the same. It's just we're looking at a table instead of pairs or a graph. All right, so I'm going to have you guys try the next one. I think the next one is also a table. Yes, so go ahead and try this one. All right, so moving on now. Again, it says because x and y coordinates are switched or interchanged to create the inverse of a function, then that means that the domain of the function becomes the range of the inverse, and then the range of the function becomes the domain of the inverse. And you're like, huh? What'd you just say? So this is the function and the inverse. What this is saying is because the x's and the y's are switched, x is the domain of the function. It's going to become the range of the inverse, okay? And then the range of the function becomes the domain of the inverse. That's basically what that's saying is. Because the x and the y switch, let me zoom in. Woo. Because the x and the y are switched, the domain is basically all the x values is going to become the range of the inverse. And then the range are the y values in the function. They're going to become the x values in the inverse, which correlates with the domain.
That is confusing.
It's basically because the domain in the function is x, they're going to become the y's in the inverse. And then the y's in the function are going to become the x's in the inverse.
So wait, in a normal function, x is the domain, y
Yes.
is the range, and then you split them for the inverse?
Yes.
Oh,
Okay. So if I look at this example here.
Do I write that down or no?
You don't have to. You can if you want to, we don't have to. Okay. So the directions here say what are the domain and range of the function and what are the domain and range of the inverse. But when we do this, it has to be in order from least to greatest. Okay. And then you also ignore like any of the values that are repeated. Okay. So if I look at this function, I got negative 5, 2, negative 3, negative 9, 7, 2, and 0, 8. So I need to talk about the function. And then I also need to talk about the inverse. So for the domain, that's the x values in my function. So I have negative 5, negative 3, 7, and 0. I'm only looking at the x's, but I have to put them in order from least to greatest, okay? So this is going to be, the smallest x is negative 5. Then my next smallest is negative 3. Then I have 0, then 7 at the end, okay? Notice I didn't have any more parentheses because it's not a coordinate pair anymore. Now I'm talking about the domain, okay? And then the range are the y values. So I can see the 2, -9, 2, and 8. I'm going to put the y's in order from least to greatest. So what's the smallest y value? -9, and then 2. Notice 2 is repeated twice, so I'm only going to write it one time. Yes, and then the last one is 8. All right, so then my range for the function, it changes to the domain of the inverse. So my domain now for the inverse is going to be the range. So -9, 2, and 8. And the domain of the function becomes the range of the inverse. So this is -5, -3, 0, and 7. Okay. All right. I think that's as far as we're gonna get to this. Your homework. I want you guys, since we didn't get to finish, just do up to number 7 on the homework, and then we'll do the rest tomorrow. So you guys are doing numbers 1 through 7 on your homework, since we didn't get to go over the rest of it.
Did we do this last year?
Probably, I don't know.
The only thing I remember from last year.
Okay, so we need to finish the lesson from yesterday. So our lesson here we didn't get to finish, but we have the this example where I'm giving f of something and it gives you a y value. So just like we have f of x is going to equal our y value, whatever we have inside the parentheses is our x, and after the equals is our y. So here I can see my x is 2, my y is 5, my x is -3, my y is -12. So for my function f, I have the coordinates 2, 5, and then the other coordinate is -3, -12. This is for the function. Now for the inverse, just like we were doing yesterday, you switch them. So this is going to be a 5, 2, and then a -12, -3. I'm just going to flip the x and the y's. So then now that I'm looking for f inverse, I'm going to be using the f inverse function. Now my x is -12, which is here, and then my y value is -3. So my answer for the first one is -3. And then for part B, I'm still looking for the f inverse, so I'm still looking at this function, but now I'm looking for an x of 5. So my x is here, so that means my y is 2. That's my answer for the second example. Okay? All right, so now this one's a practice. So the g is going to be -6, 4 and 8, -1. And then the g inverse, you just switch those. That's 4, -6, and -1, 8. So you guys can go ahead and pause this one and see if you can get g inverse of 4. Look at this one and see if you can get g inverse of 4. Okay, hopefully you notice the answer for this one should have been -6. So my 4 is here, that means the answer is -6. All right, for part B, g inverse of -1. Okay, hopefully you can see -1, so the answer is 8 for the second one. Okay. And that's pretty much it. That's the end of the lesson now. I just wanted to go over that quick last example. For closure, it's just explain how to find the inverse of a function. The main thing is you need to be able to recognize that to find the inverse of a function, you interchange or switch the x and y coordinates in every point. Okay, so now you should be able to finish the assignment on your own.